Okay, so in this video I will just give you like a brief idea about chapter 6, and then we'll jump right into working on some questions. So chapter 6 is about continuous probability distributions. Probability distributions. And to be more specific, in this chapter we are going to talk about normal probability distribution. So what we're going to do is I'm going to briefly talk about what normal probability distribution is, and then we are going to talk about how to calculate probabilities. So if you remember from chapter 5, in chapter 5 we talked about discrete probability distributions. When you have a variable, number of people in a line, number of children in a family, we thought about what are the all possibilities that it can be, what are the all possibilities of the variable, and then what are their chances. So we basically build the probability distribution. So probability distribution is all possible values of the variable and then their corresponding probabilities. So that we did for discrete variables. Number of people in a line, discrete, 0, 1, 2, 3, 4, so and so. Number of pets in a family, 0, 1, 2, 3, 4. So all discrete possible values. But in practicality, we are not going to only run into discrete variables. We are going to run into continuous variables. Right? Well, actually, we would run into continuous variables more than discrete variables. So when you happen to have a continuous variable, how do we build its probability distribution? So it's a bit complicated than the discrete case because our possible values are now in a range. So when you think about continuous variables such as, let's take a couple of examples. Temperature. It's a continuous variable, right? So when you think about its possible values, so if I name this to be x, on the x-axis, the temperature can vary from 0 Celsius to 50 Celsius. I don't know temperature in the sense of it can be the atmospheric temperature, it can be the temperature inside a freezer, so it can be different scenarios. So I'm just going to assume for this particular temperature it varies from 0 to 50. So each value between 0 and 50 are possibilities, right? So any value between 15 and between 0 and 50 is a possible value of this variable. So it's continuous. And if you think about your variable being income, let's say weekly income of an employee, so that variable can be, let's say, a $500 to $1,500. Okay, so any point between these two is a possible value, right? So it's continuous. So when you want to think about for this particular variable, weekly income, if you randomly pick a certain employee from this company, what is the probability that their weekly income is less than 1,000? So now you have a point on this range. You want to figure out what is the probability, what is the chance their weekly income is less than 1,000. Less than 1,000 means this complete region, right? Less than 1,000, that is the idea. So if you want to get the probability, like if you if you think about in chapter 5, if you want to get the probability less than 1,000, what we did is from the table we read all the probabilities and we add them together. So it's basically a cumulative probability. So we have to do the exact same thing, but in a continuous setting. So now that we have this continuous range, we have to think about a continuous way of illustrating the probabilities. So we cannot list them in a table like we did for chapter 5. So you cannot basically list all the possibilities here, because we know 1000 is a possibility, and then 999 is a possibility, and we know there's infinitely many values between these two numbers as well, right? Because 999.01 is a possibility, 999.5 is a possibility. So basically we cannot list it. So a table is not going to work. It's not good for continuous probability or for a continuous variable. So the option that we are going to use is a graph. So on the x-axis, we list all possible values of the variable 500 to 1500, which is very easy, because on a graph the x-axis is continuous. So you basically represent all your possible values of the variable, and then on the y-axis you're going to list the probabilities. So for each point from this should be 500. So from each point starting from 500 all the way up to 1500, you can have a corresponding probability reading. Right, so I don't know the shape, but it can be a very weird shape. Okay, so basically it's a curve. Something like that. So this is the probability distribution of the variable weekly income. So you can see by definition, probability distribution means list of all possible values of the variable and then their probability. So we have list of all possible values over here of the variable, and then their probabilities are here, and all the probability readings that you can get from the y-axis. So if you want to read 1000, you just go straight, find the point, and then read the probability reading from the y-axis, right? So if you want to get the probability that the weekly income is less than 1000, so you have to do this for all individual points. So you have to read every y value for this complete region. Okay, so in other words, the good thing about continuous probability distributions is that once you have the probability curve, area is actually equivalent to the probability reading. So by saying your answer, so your answer to the question, if I randomly pick somebody, some employee, what's the probability that their weekly income is less than $1,000. So this number equals to the area left to 1000 under the probability curve. Okay, so in continuous world, probability is same as the area under the probability curve. So if you manage to find the area under this probability curve, there you go, you have your answer, right? So since the probability distributions can come in many different weird shapes, we are not going to talk about all those shapes. We're just going to talk about one shape, and that shape is the bell-shaped curve. and that shape is called normal probability distribution. So we are only going to limit ourselves to talk about variables following a normal distribution. So so it's just another name, probability distribution. Like we had binomial, Poisson. We know if a variable follows a certain characteristics, we call it, okay, that variable seems to have a binomial distribution. So same goes here. If a variable happens to follow a certain characteristics, if a continuous variable happen to follow certain characteristics, we say, okay, this variable follows a normal probability distribution. So the basic idea is the variable, when you look into its probability distribution, so if any continuous variable has a bell-shaped probability curve, probability distribution, that variable follows a normal distribution. And this bell-shaped probability distribution, so if your x, variable x, whichever it is, follows a normal distribution, it must have a probability distribution, probability curve of this shape. So on the x-axis you have all the possible values, and then on the y-axis you get to read the probabilities. Okay, right. And the other important thing in terms of the bell shape is the center. So this is a symmetrical graph, right? So this is a symmetrical picture. So the center of this picture is the mean of the variable, population mean of the variable, population mean. That's the center. We know this from chapter 3. When you have a bell-shaped curve, mean, median, mode, they are the same and they lie at the center, right? And the spread of the distribution is determined by, spread around the mean is determined by the standard deviation. So this is the population standard deviation. So by changing the mean, by changing the standard deviation, you can create many different bell shapes. So if I create a different bell shape, so this is another bell shape, right? And this is another bell shape. Okay, so mean is here, standard deviation is higher, and for this one, mean is here, standard deviation is smaller compared to the other two. Okay, so you can have different bell-shaped curves, and we can calculate the probabilities under any of these bell-shaped curves using megastat. Okay, so I'm just going to jump right into the questions now. So let's have a look at some questions from the worksheet. So I'm not even going to talk about the standard normal curves. You don't need to. I'm just going to point you towards the most essential ones. Okay, so have a look at number 8 on your worksheet. Question number 8. Okay, I added it over here. Anyways, so question number 9 on the worksheet, chapter 6. The mean of a normal distribution is 400 kilograms. The standard deviation is 10 kilograms. What is the area between 415 kilograms and the mean of 400 kilograms? So we need to know what's the probability that the weight is between 415 to 400. So if we sketch the graph, so chapter 6 worksheet, question number 9. So your variable is the weight, and it happens to be a normal distribution, symmetric around the mean, 400. And the question asks what is the area between 400 and 415. So you need this area, right? Okay, so we are going to learn how to read this from Megastat. So you will have to run Megastat for twice. Once for 400, again for 415. So you need to go to Megastat probability, normal distribution. Okay. Okay, so Megastat probability, normal distribution. And first thing first, by default you would see, I'm sorry, let me clear this out. So by default this is what you see. Mean is 0, standard deviation is 1. So when mean is 0 and standard deviation is 1, we say that Megastat is set for standard normal distribution. Standard normal distribution is just another normal distribution, just another bell-shaped curve which happens to be symmetric around 0, mean is 0, and the standard deviation spread around the mean is 1. So you don't need to worry about that. What you do is you change your settings according to your question. Mean is 400. So when you change, you will see Z will be changed to X over here, right? Mean is 400, standard deviation is 10, and then up here. So you have two options. Calculate the probability for given X value. Calculate the X for a given probability. So right now what we're trying to do is calculating the probability, right? So the area, this red area is the probability. Calculating the probability for a given X. That's what we are trying to do. Okay, so the default option. So we are going to read 400 because we have two different limits. So we need the area between 400 to 415. So first I'm going to read 400. So I'm going to set this rounding to 2. So when you set rounding to 2, what happens is that this is only for the homeworks because homework uses the manual table reading, not Excel. So our answers may not match with connect answers. So to avoid that problem, you can set the rounding to 2. Okay, here you go, and I'm going to run it again. Go back in, normal distribution, change the number this time to 415 and run again. Okay. Right, so now let's have a look at the outcome. Okay, so let me see if I can copy paste this over to whiteboard. It's very tiny. Okay, good. Here you go. Okay, so now you need to pay attention to these details. What does each number means? So basically this is all you need. So this lower reading, so 0.05 for 400 and then 0.933 for 415. So what happens is this. So under the normal distribution, here's 400 and here's 415. So this lower reading means, for example, for 400, lower reading means the complete area all the way to the end. Complete area to the left of 400, so which happens to be 0.5. Okay, and then 0.9332 is the complete area left to 415. So the complete area left to 415 is 0.9332. So what we need is the area in between. So basically what we need is the green area. So our green area equals to red area minus the black area, right? So the red area, the total red area is 0.9332 minus 0.5, 0.4332. There you go, answer to the question. Okay, so I'm going to do one more from the worksheet. Then let's talk about the other side. Okay, number 12. So the employees of Cartwright Manufacturing are awarded efficiency ratings. The distribution of the ratings approximates a normal distribution. The mean is 400. Standard deviation is 50. What is the area under the normal curve between 400 to 450? Okay, 400 to 482, sorry. So question number 12. So variable x is the ratings. It's normally distributed around 400. And standard deviation is 50. We need the area between 400 and 482. Okay, right, so we go back to Megastat. Normal distribution. Mean is 400. Standard deviation is 50. I have to run for 400. And then run again for 482. Okay, so I'm going to get the two lower readings, 0.5 and 0.9495. Okay, so the total area to the left of 400, black area is 0.5, and then red area is 0.9495. Is that 9495? Yeah, 9495. So the green area equals to red minus black. Okay, so 0.9495 minus 0.5. Okay, it's 0.4495. That is the area in between. So you can pick any two. So just take the same question, pick the two different numbers. Just pick any two different numbers. And then read it from the graph. So read it from Megastat. So you can pick, so as a practice, try what is the area in between 395 to 410. See if you can figure out that. And also as a practice, take the same picture, same probability distribution, 450. Mean is 400, standard deviation is 50, and see if you can figure out what is the complete area to the left of 450. So if you want to get the area to the left of 450, that means you're directly reading the lower reading, probability lower, right? And if you want to get the area above a number, so I need the area to the left of 350. Sorry, area to the right of 350. So that means you're reading probability upper. Okay, so here you're reading probability lower. So you can read, you can calculate the probability that the variable is more than something. You can calculate the probability that the variable is less than something. You can calculate the probability that the variable is between two values. Okay, And the other side is, if I go back to Megastat, so the other option, calculate the x value for a given p. That's the other side of the calculation. So so far what we did is we know the point on the x-axis. We know it's 350. We need the area, right? We know it's 450 and I need the area. I know it's 400 and 482. I need the area in between. So now I need the complete opposite. I need to find out which x value, which value of the variable has an area of 95 to its left. So now I know the area. I need to know what is the x value which bounds that number. Okay, so this is a direct reading from Megastat. So you go into Megastat, select the second option. So I'm going to assume the same mean and standard deviation, and you need to provide here the area to the left. Always in Megastat, when you are using the second option, calculate x given p, this option, you need to provide the area to the left of the x value that you are looking for. Okay, and click OK. Right. So from the third reading, sorry. Okay, so this line. Okay, so this is the x value. So 482. So this x value is actually 482. So 95% of the area is below 482. That is the idea. So if I'm giving you another example, let's say that exam scores are normally distributed. With mean 75 and standard deviation 10. So I'm interested. So this is my result. I know the exam scores of all my students is normally distributed. And I'm interested knowing, let's say 85% of my class scores are below which grade? 85% of the students of my class are below which grade? So if the question asks 85% of the grades are below which grade? So what that means, you have your normal distribution, exam scores is your variable, 75 is the mean. So 85% of the area, 0.85% of the area is below which grade? Right, so this is the average grade, 75, and I want to know 85% is below which grade. So you go up here, back into Megastat. Mean is 75, standard deviation is 10.85. Probability. Here you go. So 85.4 is the x reading. So this number equals to 85.4. So 85% of the scores in my class are below 84.5. So sometimes in the question you will be given the area to the right. This part will be given 15% of the top 15% of the grades would be above which number. So whenever you have given the area to the right, you are not going to use that. In Megastat, always by default, you have to use the area to the left to figure out the point. Okay, so if 15% area to the right is given, then you have to do 1 minus 15%, which is going to be the area to the left, assuming the total area under the curve is 1. Okay, so so those are the two sides of the calculations that we have done in chapter 6 and how to use Megastat.